How's that?
There we go. Good morning, everybody. My name's Kurt Ferguson. If you've joined us for other webinars, you might recognize me from one last week. But if not, I'm one of our Houston regional managers, and want to thank you for joining us for Level Up with IO-Link. This morning, we're going to be getting into a variety of IO-Link products and a description of the technology. So hopefully, everybody finds it beneficial and a way to utilize it on your equipment. We're going to go ahead and mute everybody that we can. If you're on here and if you can mute yourself, that'd be great. If not, I'll go through the list here in just a second. For those that aren't familiar with Automated Dynamics, we're a web firm based in the South. We are in 6 states: Texas, Oklahoma, Arkansas, Louisiana, Mississippi, and Western Tennessee. Everywhere you can see the little Fisher-Price guys there is a territory manager in the red. In the blue, those are our FAEs and where they're located. FAE for us is a field application engineer. So they're there for additional technical support when things get beyond our capabilities, and they deal with our more advanced products. IO-Link being one of those topics they're all proficient in as well. We're here for support, so please give us a call if we have assistance. Moving on from there, Carter, can you index 1?
I can.
So this is the guy that's going to be talking to you today. Unfortunately or fortunately, hold on, I got to get somebody on this. Carter Massey's been in the industry since 1992, been with Automated Dynamics since for 22 years, married for 30 years straight. Congratulations on that, Carter. On that 30 years continuous, that is quite the accomplishment. I'm going to do my best to keep everybody muted on here. So please use the chat for questions. For those that aren't familiar with what the chat is, it's in the upper right-hand corner. There's a little bubble. If you hover over it, it says chat. If you click on it, it allows you to put in a message. Please, whenever you're going to send it, please make sure you're sending the questions to the organizer. That's me. I'm going to be monitoring the chat. Carter is the presenter, and so he will not be able to see those. So we won't get to your questions. So please make sure you send them to the organizer, and I will interrupt him periodically with questions that come up. Just a couple of tips for probably better viewing on here. If you go up to the top where it probably says view everyone currently, if you'll click that and go down to active cameras, that will narrow down the screen size to only those cameras that are live right now. And then the other thing you can do is if you're running 2 monitors, on the right-hand side of your screen, there should be a little controls box rectangle. Within that, there's a circle with 2 squares. If you hover over it, it says detach cameras. If you click that, that allows...
Uh-oh. Did we just lose Kurt for a minute?
So apparently whenever I clicked it,
Did everybody lose Kurt or just me?
Nope, he's been lost.
He has been lost.
Once he clicked it, we lost him.
Yeah, exactly. All right. Well, he was probably going to just say wonderful praises about me, things that were going to embarrass me that were probably true, but still, it would embarrass me nonetheless. You there, Kurt?
As soon as I clicked those 2 squares, it kicked me out of the meeting. So that's not a very good testament there. But anyway, you can detach the cameras and move one of the cameras to your other screen if you are running 2 monitors. But other than that, I will quiet at this point and let Carter take over, and I'll get back on at the end of the presentation and wrap up. So it's all yours, Carter.
Thank you very much, Kurt. Good morning, everybody, and welcome to this Level Up session. I'm a little older, but embracing some of the gaming terminology. So this session here is all about leveling up with IO-Link. If you are attending this meeting, then you've either got some experience with it or at least are interested in IO-Link and have heard this buzzword going around for a while. So what are we going to talk about today? Well, we're going to talk about what IO-Link is, and almost just as importantly, what it isn't. We're going to talk about the different ways to use IO-Link. I will tell you that this is less of a how-to and more of a why-to and a what-to. We can do some deeper dive, how to do everything in future sessions with one of our phenomenal field application engineers. But I've had several applications that we've solved with IO-Link that made it an obvious choice, and I think it's something that people might be misunderstanding somewhat. So hopefully we can clear some of that up. Definitely get into the advantages and of course the fine products that we sell here at Automated Dynamics that support this. Giving a presentation to a bunch of people I can't see and read body language and stuff, I'm just going to assume the dad jokes fall where they need to, and that you guys will laugh hilariously. In fact, I might even add some pause for effect every now and then to give you plenty of time to laugh and recollect yourself. But what's even more disturbing is, you're kind of used to all the oohs and the ahs when you're talking about some of the great technologies that our partners come up with. So I had to provide my own oohs and ahs. So it does something for me. So here we go. Let's get into what is IO-Link and of course what it is not. Let's start with what it isn't. When I first heard of IO-Link, my first reaction was, oh great, another field bus to try to get people to jump on board to, because we had seen some successful implementations, but we had DeviceNet come out, we had SDS if you've been in the industry for a while, Profibus DP, and then of course Ozzy. Everybody talked about how these things could play together, and they could, but they weren't applicable for everybody. And in fact, each of them required a substantial investment up front, and it kind of prompted you or made you choose a platform when you're just getting started, and that's what I was thinking the industry doesn't need another one of. So it's not but one thing I've discovered is it's not a field bus. It's down to the sensor level, and you can use it in a very introductory method. A lot of the sensors you're buying today might even have the technology integrated into it, or you can plan a whole automation platform around utilizing the technology. So it's not a field bus. I also discovered it's not something to run from. Because you can kind of put your toe in the water, and I'll show you kind of how you can do that, you can start slow and then build up as you become used to it. It's also not a social media site for people with lots of credit card debt to connect with each other. That is IO-Link, and their motto is in love and in debt. So let's kind of get into what it is instead of what it isn't. Oh, I'm supposed to pause for laughter. My wife's rolling her eyes. Okay, so this is an example of kind of where automation has been in the last 20, 30 years. You've got all of these devices because we need to sense something, measure something, do whatever, and we need to get this information into some type of programmable controller so we can make decisions, record data, that kind of thing. And people love to record data. So historically, all of the intelligence was at the PLC or even maybe some other remote I/O level. And so there was this barrier of knowing what was going on down at the end device, other than it's on or it's off, and you're giving me some type of variable measurement. Well, how do we know if that level transmitter is having an issue or not? Well, we don't until it quits working, and we just have to make some assumptions. But what IO-Link does, and I've heard it said pretty well, it brings intelligence down to the last meter of your application. And so we're going to put the intelligence down into the devices. I told you it's not a field bus. It is a communication method. There's a microchip buried in each of these devices that speaks this IO-Link protocol, and it's point to point. So just like an analog device, if you want to measure a 4 to 20 off of a pressure transmitter, then you're going to take it into one point of your analog input card. IO-Link is similar to that. If you want to measure pressure with your IO-Link sensor, it's going to come to one point on your IO-Link card. It is an open standard, which so is like 4 to 20 milliamps, right? So one of the big benefits to the customer is you're not locked into a solution provider. We as a rep hope to earn your business with support and technology and things like that, but it is an open standard, so it allows you to deploy products from multiple companies, and it also doesn't lock you into something. What can you get from IO-Link? Of course, we're going to show you how you can get measurement, you can get status, you can get health, you can get so much more. Another cool thing is if you're used to running analog signals, typically you need to run shielded cable, or you should run shielded cable to make sure you don't get interference and things like that, especially if you're running at a pretty good distance. Well, this was designed to use the same 3-wire unshielded cable that proximity sensors have been using for 30 years. And you can take one IO Link device over that 3-wire cable up to 20 meters to the IO Link scan card, the IO Link Master. You can use this for diagnostics, configuration, and it updates very, very fast. You can go modify how often you want something to update, but you can have it update as fast as 2.3 milliseconds. And I'll show you exactly what that means. Okay, so what does it look like now if you're using IO Link? Well, if you're using IO Link field devices, you still got your field bus. So we're not replacing the field bus. You can get IO Link devices and scan cards and things for the different field buses. The most popular one these days is definitely Ethernet, with Ethernet IP and Profinet being the most too common. So now we can put some intelligence down into that middle layer. Oh yeah, I get to use a little laser pointer, don't I? A laser pointer. So in its middle layer, these are all intelligent devices that have the IO Link chip in them and are reporting back the measurement as well as some other diagnostic data if your controller is programmed to take advantage of that. And then down here at the bottom level is conventional, just discrete on-off I/O. So even using IO Link, we can still utilize it to help us gather just some basic proximity sensor, valve actuator, signals like that. So you don't have to make a choice of IO Link or discrete. You can actually implement both, which I think is a pretty cool thing. This slide, I'm going to come back to this slide. I decided to come back to it. It's going to show a lot of the things that we can do in IO Link together compared to how we did things in the past. But first, I wanted to get to what can you get from an IO Link device. I'm not going to get into the bits and bytes. I will just tell you that first and foremost, you get processed data. You don't have to ask for this. It's going to be updated every scan of that port. And typically, this is going to be, is my sensor on or off? It's going to be the measurement if you're measuring like laser distance. You're going to be writing to the level of your actuator if it's going to be on or off, or if it's a absolute position actuator, then you're telling it where to go. So this is going to happen every single scan without any type of manual coding. The other type of data is where it's available if you want to grab it. Commonly, people might grab it periodically, or they might go check it out if something is, come back as unhealthy or iffy. An example here is some devices, and it varies by device. Some devices let you look at the actual temperature of the device, how many hours it's been operating, what the serial number is. So from an OEM standpoint, you can actually know if an end user changed out your product. You can even recognize that on your PLC and alert that somebody has changed out that sensor. So there's lots of different things that you can get in that other data called acyclic. So let's get into some of these advantages of IO Link. This is kind of the toe in the water advantage of IO Link, which is sensor configuration. If you're looking, now look at the camera here. This is a little photo eye that is can be used as just an on-off photo eye, but it does have IO Link built into it. And if I can figure out how to change my screen share. Aha, here we go. This should pull up. I've got a software open. It's kind of an open consortium software. Kurt, can you see the Pactware? Yes, you can.
Yes, I can.
Okay.
Yep.
Yes.
So what this is doing is I've got this photo eye. It is an IO Link device, but I'm not ready to use IO Link out in the field. I just want to use on-off sensors. But what I might have done is run into an application where I want to add a time delay to a simple photo eye. Well, since this is an IO Link photo eye, you can actually go configure it using IO Link and then deploy it as just a standard on-off sensor. I've just got this pulled up, and here's some of the examples of things you can do. You can change the light operate, dark operate status. You can enable this on or off delay, and then you can actually put a time delay into the photo eye. So if I were to have this hooked up to my IO Link master, connected, and I've got this nice Turk block over here right now, but there's also just like a simple USB IO Link master. So I could set this up on my bench, tell that sensor through this some free software that I need you to have a 2500 millisecond time delay. Download that into the sensor, and then just go take the sensor off the bench, put it into my application, and now I have just a standard PNP photo eye that has a time delay built into it if I needed to put in a debounce or a jam or something like that. So that's just from a discrete sensor. This example I like even a little better. This is a Turk temperature transmitter. It's got a 4 to 20 milliamp output. It's got a PNP switch output, and it's got IO link. So if I'm, again, not ready to go just read the IO link temperature value, and we'll do that in just a little bit, what it is, I've got maybe 5 applications for a temperature transmitter, but I want the 4 to 20 milliamp output to represent different temperature spans. It comes out of the box like 0 to 150 C. So what I can do, I can come on here with my software, and I can basically set the end point of my 4 milliamps, the end point of my 20 milliamps to anything within this temperature range. And now I'm able to use my 4 to 20 milliamps over whatever temperature range that I want to. So again, I connect it to my simple USB IO link master, set up my 4 to 20, and you can also do the same thing with the switch point. If I want it to be 100 degrees in one application or 150 in another application, I set it using the software, disconnect it from the master, and then just go use it as a simple 4 to 20 milliamp transmitter with my existing control system, or just a PNP temperature switch output. So that's how you can just kind of stick your toe in the water with IO Link and take advantage of the technology without having to redo what you're doing from a control standpoint. Now let's get back to this. All right, so we should be back up onto the screen now with the PowerPoint. All right, so what else can we do? I'm navigating my screen here. Let's go here. All right, there we go. So another advantage of IO Link is simplified wiring and cost reduction, which those are two things that people really like. What's funny is when we went back to some of the other field buses like a DeviceNet, we looked at simplified wiring, but we had, for the purpose of long goal cost reduction, but we had to put in an ROI calculator maybe because the hardware was more expensive and that kind of thing. Here we can get some instant savings even before just the hardware, even before we get to the wiring savings from a labor standpoint. So what we're dealing with here is this is the traditional method of handling this type of I/O. You've got a rotary encoder right here. That's in this particular application, it had an SSI type of output to get the high resolution. We had a pressure transmitter that was given, or it's a temperature transmitter, giving us a 4 to 20 milliamp into an analog device. And then we have our traditional multi-port breakout boxes. Everybody's kind of familiar with these things throughout the years. You can have 1 or 2 sensors per port. You got your multi-pin home run cable. It kind of consolidates your wiring, and a lot of advantages there. But what we're looking at here in the cabinet is I've got 2 discrete I/O cards. Actually, I've got 3, a couple outputs, a couple inputs, and then I've got an analog card and an SSI card. And then this, of course, is what it looks like in the wiring for the panel. If I go to something like IO Link, then it really cleans it up. So now our encoder looks just the same, but this version is an IO Link version. So instead of having the high-level expensive bus of SSI that requires its own special card to just read one sensor, now I've got an IO Link encoder. I've got my temperature transmitter that has IO Link in it as well. And then I mentioned the multi-port block. Well, now we've got something like this up here. Look at the board. So this is does the same purpose as something like this, allows you to put a lot of digital I/O signals together. But instead of that multi-pin home run cable, it's an IO Link device that has just a 3-pin cable running back to my IO Link master, which is this other block over here. And I should mention in this panel, this is an IP20 solution on DIN rail. We've got the Ethernet gateway, and then this is just a 4-channel IO Link card. That also has 4 additional discrete I/O. So if you look at the panel, you'll see we only landed the 4 wires from each of the IO Link devices and the plus and the minus to power everything up. And then out in the field, we're dealing with much smaller cable, much easier to route, easier to protect, and much less expensive. So we're doing the same thing with these 2 bill of materials. There's the difference in the panel. So we've saved panel space, and we've saved a whole lot of wiring, which is a potential for a wiring mistake. There's what it looks like out in the field, even a little cleaner with the thinner cables. And here's the real thing here is that on the left is that standard wired traditional solution at a $2,300 hardware cost. And on the right-hand side is using it with IO Link. So we save wiring and we save space. We've also saved money with our hardware. When we're looking at sensors like an analog versus an IO Link, oftentimes the IO Link sensor is the same or less than the analog, and the same goes for the IO card. And like we just showed with this picture here, the IO Link card can also handle more than just analog signals. I've got discrete IO on here, as well as multi-port discrete IO out in the field reporting back to that same device. So that's going to take me back.
Carter?
Yep.
Hey, got a question. What kind of diagnostics can you get from the hub as a question that just came through?
You know, I'd have to dig into it specifically, and please get that person's information down. There is a list of things that you can get, so you can check for shorts, things like that, but I don't know the complete list, but great question, because it is more than just I/O. In fact, this one here that I'm looking at, it's got a little red blinking light because I didn't have this is a special one that lets you power up each side with a different power supply, so you can separate input from output power, things like that. And so the error I'm getting from this is telling me I have an undervoltage on the right-hand side. So that's one of the diagnostic bits of information. Great question. So I'm coming back to this slide. Where I have really found a lot of use for IO Link is any application, customer, machine builder, integrator who's dealing with a mixture of discrete and analog signals. Historically, if you're using remote IO, like in this application, you're using multiple IP addresses for your different types of IO. Here's an example. So if I was going to do analog and discrete in the past, now if we're on the camera, I might be using a couple of different blocks. This one is just a traditional 16-point IO block. Any point can be an input, any point can be an output. And then here, I've got the top half of this block is analog input. So I had a location where I wanted to do analog and discrete. Well, then I would need to have two blocks, so I would need to take up two IP addresses. The cost might prevent it, but it might still be worth it. But then oftentimes I end up with a lot of empty ports. So going with IO Link, if I use an IO Link device instead of an analog, and I use an IO Link brick for my like a little hub like this for my discrete IO, now I can do my absolute measurement and my discrete IO all in one IP address and save a lot of space and money. Now the other thing I'll mention is here's a handy 3-color tower light with an audible. Well, this is typically going to be 4 outputs from your PLC. So if you're using an IO Link, I'm sorry, not IO Link, but an IO block method traditionally of discrete IO, we had to make the light. It was handy. We could make 2 cables coming out of it with 2 connectors, because if you're going to use more than 2 outputs, then you have to take up multiple ports. So if I've got a couple of tower lights in this application at this drop, well, I've just taken up 4 ports. What we're showing here on the slide on the left here is if you get like an IO Link indicator device, well, now no matter what you're doing, you're only taking up one of those ports. If you look at the board, this is a 10-segment tower light, which is pretty cool. This is a little actuator with an LED indicator we'll turn on here in a second. But now we're just taking up one port. So besides just the analog and the measurement and the discrete, now I'm able to do measurement, discrete, and indication all in one IP address and take up just one space out in the field. So just some ideas here. We've got our hub that we talked about before. We got 2 of these. So right now, and these all just take standard discrete IO. This is 32 points of IO coming out of these two ports. People use IO Link sometimes just to get high density discrete IO out in the field, and I'll show you an application example for that in a moment. Here I've got a pressure transmitter. That's no longer a transmitter necessarily. Now it's a pressure sensor with an IO Link signal. My indicators, laser measurement. This is a easy array from Banner, so it's actually doing dimensioning. This is that encoder we talked about earlier, and here's an RFID reader from Turk. So now, instead of having a separate RFID station out in the field, I can lump all of this together so I can do my trigger sensor, my RFID, and my local indicator all in one block and IP address. All right.
Hey, Carter?
Yep.
Got another question. The question is, what is the max length from the TBEN L5 8IOL and gateway? Is it 20 per length? And I'm wondering if by gateway they're meaning the PLC possibly.
Okay. Well,
So
I'm sorry, Kurt. Go ahead.
Yeah. So I think the question is that limitation 20 meters as well?
Okay, great question. So we'll handle both possible interpretations there. One is each of these IO-Link ports, I can have 20 meters each one. It's not a total length of all devices. I can have a 20 meter cable from each port to its IO-Link device. And then in this block, this is either going to do Ethernet IP or Profinet or Modbus TCP and the same hardware. Now we're just playing with Ethernet rules. So the typical Ethernet rule would say I've got 100 meters before I need to go to another switch. So if you've got switches along the way, then you can go an incredibly long way. Here's an application that the customer didn't really ask for IO-Link. What he said is, I've got a put the light application. So basically, each one of these lights represents a little cubby that the operator puts the product. And they needed a light to come on to let them know which cubby, cubby's not a very industrial word, which inventory slot that the product needs to go in. So this would light up green to let them know. If you probably can't see maybe, but these are also touch buttons. So every single one of these devices has an input and an output. When we first looked at this, we were trying to figure out the best way to deploy this and wire it. What we ended up doing, now I've come back to the board, you could tell we used 5 of these hubs and 1 of these IO-Link, 8-port IO-Link masters, and it just cleaned up our wiring and our cost very easily. So I've got, simple cables running out to each of these devices, and then I've got each one of these landing into this port. So we didn't have to land any wires out in the field whatsoever, and we were able to do this pretty simply. So this became an IO-Link solution based on the need, not somebody asking for IO-Link. We've done this with a few different applications. If you've got a lot of discrete I/O in an area, then this can really clean it up and reduce your cost. I mean, historically, the other thing you might do is a bunch of I/O blocks with Ethernet, which we love selling I/O blocks with Ethernet, but it's an unnecessary expense in this application, and now you're dealing with multiple IP addresses, which some PLCs will limit the IP addresses that you can have unless you upgrade. All right, so then measurement signals. I definitely avoid the word analog when I'm talking about this, because analog to me is a variable signal. But historically, for an application like this, we use an analog sensor to do loop tension control. The challenge is if you've got 5 lines, then you're running, shielded cable, back to a PLC, for instance, and then you have to scale each and every I/O point of the PLC. You might even have to teach this sensor. This particular sensor has up to a 12-meter range. Well, if I'm using this in an application that only requires 6 feet, I don't necessarily want my 4 to 20 milliamps to be 50 millimeters to 12 meters. That just means in this application I only be using 4 to 6 milliamps. And some people just don't like to do that. You want the numbers to make sense. So you end up teaching the sensor, and then you end up scaling the PLC. The challenge comes in that 2 o'clock breakdown when somebody needs to change out that sensor. Well, they might have to reteach it. And reteaching sensors, while it's handy, it can be confusing for some folks. So if we're using an IO-Link device instead, and now this is conversely, I forgot my dad joke lead in there. Conversely, if we use an IO-Link sensor, just a little small shoebox PLC like this one, now instead of an analog device, we're actually sending it units of measurement down into sub-millimeters. That's not necessarily the resolution of the sensor, but that's the message that we're getting. So now instead of having to teach the sensor and scale the analog card, now we can just read the distance coming from the sensor, how many millimeters away is the target. Also too, when you're changing it out, 2 o'clock in the morning, if something happens, there's no teaching the sensor on what to do with the application. Either the sensor can be used by default, or as we'll see shortly, the IO-Link master can be programmed to configure the new sensor whenever it's connected. Another advantage here is sensor cost was less, And we also used 3-wire unshielded cable once again. I don't want to undersell that fact.
Hey, Carter.
Yep.
So I guess there was a slide you had on there that had multiple green lights on it.
Yep.
And the question was, yep, that one right there. So there's a question on cable limitation length of the black cable going from the IO link. I assume that's TBN.
Yep.
IO link going to the hubs. Those are going to be 20-meter limitations as well, correct?
That's correct. Each one of those can be up to 20 meters.
And then how about the yellow cables dropping off to the lights?
So those are just 24 volt. Actually, the lights are like 12 to 24 volt. So you can run those hundreds of feet if you wanted to. The main thing is just making sure your voltage drop, isn't too small by the time it gets to the sensor and back. So it's another nice thing about that. Is that it?
You got it.
Thank you, Kurt. All right, here's a bonus slide after one of our outstanding field application engineers called me the other day to say, hey, here's something I talk about with IO-Link. Most analog input PLC cards have like a 12-bit resolution. Some might get up to 16-bit. Well, this is the Banner LM sensor. It has 19-bit integer for its measurement data. So if I've got a 12-bit analog input card, then I'm really missing a lot of the resolution that this sensor is able to give me. If I'm using an IO-Link, the IO-Link portion of this sensor, then I'm getting that full value back into my PLC, through an Ethernet message instead of analog. So it's also just better for your application sometimes based on the resolution that you need. So thank you, John. Oh, this is my example of overstuffing a suitcase, trying to fit 19 bits of measurement data into your 12-bit analog sensor. And then we get into data storage mode and validation. If you set up your IO-Link device, and I've got one set up here that I'll show in just a bit, it can actually recognize a new device and send the proper configuration for that device, into it. A good example might be some of our laser sensors. Actually, this color sensor is a good example. This color sensor has different modes that it works in. So even if I'm getting my messages over IO-Link, the sensor's got to be in the right mode for it to give me the message that I want. And if that mode is different than the default setting from the factory, well, if I've got this port set up to do a data storage and overwrite, then as soon as I plug in a new sensor, it's going to overwrite the configuration to the sensor to be in the proper mode that I want. So now I can just freely change it out with a new one, and it's going to be ready for my application. You can also not do that if you don't want to, but it's certain applications it's a big deal. And then of course IIoT, the acronym that I wondered what the heck it meant for the first few years it was used, but now we're really starting to see some of this. If you're getting more, people are not going to want less data going forward. They're going to want more. And there's actually really, getting more and more good reasons for the data. I mean, if you're shut down, then you're not making what you need to be making, for your company, and therefore the dollar flow is shut down for however long you're down. So if we can get more preventative maintenance data to help us, do things when the machine is down, instead of taking us down for a reason that maybe we don't know. Here's a good example. Now let's see here. I'm going to now pop over to this live demo, and I've got this photo eye connected. I struggle with the screen sharing, so let's share that. Boom. So you guys should see, so this is my HMI up here, but since it's a Redline HMI, I've got a built-in web server, so we're able to view what's going on here. So in this particular device, my sensor, looking at the reflector, you can see here my output state is on, my health is good, and marginal light state is off, which means that I'm getting plenty of signal strength. In fact, here's my signal strength. It's 223 arbitrary numbers, I call them ALUs, arbitrary light units. But it's important to know that when the sensor gets blocked, now you can see that it's on, and my signal strength goes down to 0. Well, if I'm in an application where my reflector has a tendency to get misaligned, dust buildup over time, well, I would like to know that before it just quits working. So if you're looking at the signal strength, I also want you to look right here at the marginal light state. And if I start to rotate this, you'll see the signal strength come down, and I set it at basically like 155. Too much coffee. All right, so now my signal strength is 111, my marginal light state is on, and of course my sensor is still working. So what does that really mean? It means that I've just got my PLC just recognized that, hey, this is getting marginal. Next downtime, go and clean off that reflector, readjust it, do whatever you got to do. So now we just potentially prevented some downtime from a simple photo eye. And do you see the light blinking? I don't know if you can or not, because lights do weird things on cameras. That's also a local indicator that, hey, I'm working, but my signal strength is marginal. What's kind of cool here is historically Banner decided, or each sensor manufacturer, the best one being Banner, of course, Banner decided what that signal strength indicator was, which was somewhere around 104, 108. With, just so you know, the signal strength of 100 is enough to turn the output on. With IO-Link, I was able to go set this to 159. So if I look at this signal strength in my PLC right here, and I see that I'm at 232, then I can have a set point in my PLC determine when this is going to be a challenge. So then we can monitor the marginal light state and then go do some preventive maintenance. Now, something else playing with this sensor that I discovered is in that process data, we've got those top 4 pieces of information, actually top 5, but you can also give some other information. In this particular case, you can give count, you can give duration of the last signal, or you can get events per minute. And I just got to thinking about this, thinking, man, now I've got a photo eye out in the field that can really act as a rate sensor. So if I just start doing the off and on, you'll see the rate jumping up to 216. And I think in our application we got to be doing 500 a minute before we're making money. But now you've got a very cheap and easy rate indicator out in the field. In fact, if you're doing high-speed counts, historically you got to get a high-speed input card and run your signal into there, because your sensor might be going off and on before the scan time of the PLC can pick it up. But I got to thinking, well, what can we really do with this? So if you'll bear with me, I've got my Cobalt brushless motor and a paddle bit. So now you can see that we're getting rates rising up. If you're a fan of Spaceballs, once we get up to like 150, now we're at ludicrous speed. But I really just wanted to see what we could do. So if I've got this position right, can we hit 5,000? Yes, look at that. So with that, we're able to get 5,000 RPM feedback back to the PLC without having to hide a high-speed input card or do any rate calculation in PLC code. I thought that was pretty good for a $100 sensor. All right, I think that might be screen share. Let's go back here real quick. So what kind of IO-Link products do we have? And we're going to play with the board here in just a second. From Turk standpoint, we've got these different IO-Link masters. On the board here, I've got the IP67 version. So this is the 8-channel. This is the 4-channel. The 8-channel has a couple of different features to it. On the left-hand side, it's got pin 4, which is the black wire typically on a M12 connector. Pin 4 is your IO-Link channel. Pin 2 then is unused from an IO-Link standpoint. Well, in this block, every pin 2 on the left side is an available discrete IO. So I can put in a splitter here if I want to, have my IO-Link device come into one of these leads, and then have the other one go out to start hit a motor, turn on a light, do something else that's not IO-Link related but just discrete IO. The right side is has a secondary power supply. That's why this is connected to this. So I actually have 2 power feeds coming over here to this block. It's called the B wiring of IO-Link. So I can have separate power for this side versus this side. If you have some solenoids over here, you might want to have that separated from the power for some of your other devices. your discrete I/O. So those are the IP67 versions, IP69. They're built like bricks. They're both Ethernet, and we do multi-protocol. So these bricks are Ethernet IP, Profinet, and Ethernet IP all in one. You don't need to configure them. It recognizes the master that comes on board, and it reports accordingly. And we have AOI information or catalog file information, integration information, so we can help you get the data to the proper place inside your Rockwell or your Siemens PLC. Recently had a customer that was doing an Automation Direct PLC with Ethernet IP, and we were able to get the block reporting just fine. This is a little IP20 version. You can either get it with the DIN-rail bracket or without. It's a 4-channel I/O link master, and any unused port can also be used as a discrete I/O point. So again, all the devices have built-in switch. This also supports the multi-protocol. This product here was on the board that we showed the picture of earlier. It's kind of a BL20, so it's a buildable backplane. That's a 4-channel I/O link master, so you can have multiple versions of that. I had a customer that was using the BL20 as their PLC for their machine, and it was all just discrete I/O, and so we were just using discrete I/O cards. He decided he needed one measurement signal, so we were looking at an analog sensor and an analog input card. It was really going to take him out of his budget to add that, so he was looking at not adding the feature. What we did is we looked at, he only had 2 discrete in, 3 discrete out. So with this application, we were able to get rid of his discrete in and out cards, go to an I/O link card, use the channels that weren't being used for I/O link as just discrete I/O, and the one I/O link channel went to a laser distance sensor with I/O link. So he was able to get rid of some cards, go to I/O link, and combine his measurement and his discrete I/O points. Then I also mentioned RG down here. RG is in the standalone blocks like the IP21 like this and the IP67 ones. It's actually a web-based programming language, so you can do some local code in the device right here. This one was an example where somebody wanted to do crane collision avoidance, which you should do crane collision avoidance. And it had 4 I/O link channels and then 4 I/O points. So we used 2 I/O link laser distance sensors, to measure how far the cranes were from each other. We used the other 2 I/O link channels. You can go online with them with the web server and change them from I/O link to just discrete input, because he needed 2 push buttons to teach his limits on site, because they had different sites where they would sell this equipment. And then he used each of the 4 available outputs to turn on the starters to do a stop or to turn off the starters that was doing like a stop and a slowdown. So with this one brick, no panel, no extra PLC, he was able to do his collision avoidance logic and handle all of his discrete I/O. If he needed another input or output point, we would just add one of these into one of the I/O link channels. The other thing it did for him is, the main reason they were looking at I/O link to begin with is the sensor was giving him more than measurement. There's some health information to let him know target stability, what's going on with the sensors. So if there was anything iffy from the diagnostic standpoint, they would shut down, and they could shut down safely instead of having something happen during crane movement. Turk also has a whole lot of I/O link sensor products. Obviously we hit the hubs, we got pressure and temp. This is a new level sensor, level probe that Turk has. We hit the temperature probe already. RFID, linear measurement, ultrasonic, encoders. And then getting over to Banner, they have lots of I/O link products from the sensor standpoint and the lighting standpoint. And the lighting is also what's really made a lot of these changes. Look at the light here on the right hand side of the board. This is one of our tower lights that's I/O link. Every segment has RGB LEDs, so you can make any segment any color, and you can do lots of animation options. So here I'm just going to run through some of the things you can do. So obviously, and I know the lights are superior to the camera technology, so you might not be able to see everything that's going on clearly, but this is kind of like a level mode. So based on the level of a tank or how close a forklift gets to the back of a truck, you can do some indication that way. This is just showing how the light. Yep.
Hey, I was just going to tell you that that TL50 at the angle you have, it shows well compared to the K50 Touch.
Oh, thank you.
So that shows up pretty well.
Well, excellent. Well, then you guys are enjoying the show. So there's our chase feature or rotate feature, which is really common when you're starting up a motor. You can also do different sequences of startups. You know, this light has more features than Carter has pills. And if you've been alive for quite a while, you understand that reference. But that also means if you've been around for a while that you've been a liver for a long time and you understood that reference. Hopefully you're chuckling. And Kurt mentioned this K50 touch button over here. This is a multicolor indicator using RGB LEDs, and it's a touch button. So now we've got feedback and actuation, and this is the one that I was playing with earlier that it just doesn't come through the camera well. But if you can tell, you can probably see that it changes when I touch it. So this is an IO-Link device that through your PLC programming, you can make it do any of these functions, you know, basically on the fly. It's another example of why you might want your IO-Link port to do some configuration, because these have different modes to be in. And so when you plug in the tower light to the port with the data overwrite mode, now it's got the right mode and it's ready to go. And I get the feeling that that light might be just a little annoying. So now that we're adding indication into this to do measurement, measurement, on-off, and indication all in this same technology is pretty darn cool. Here I've got a color sensor. Now let's get over back to the web server, screen 1. Share. So you guys should be coming back to my Redline web server. We've already done the sensor. Now let's go home. All right, so let's go to the color sensor. So now this is a true color sensor, and it's only got a few wires, but through IO-Link I can teach it up to 7 colors and get feedback on which color that actually is. So here, if I bring this in, you see we're getting orange. This should say apple. Here I'm getting blue, and then here we're getting black. So now we can just, if we have a line and we're sorting based on color, or if you're wanting to see if the color is getting a little dimmer over time and you might need to replace some ink in a printer, you can use this for that as well. So not only can it identify the color that I've taught, it can also return over IO-Link the actual RGB values of the color that it's seeing. So as things start to change, you can watch those values change over time to once again get some preventive maintenance so that you end up not making a product that doesn't pass your QC inspection. All right, let's go to temperature probe. So here we got the temperature probe, and now you can see here that we're just reading it over IO-Link. Even though it does have analog and it does have discrete, we're just reading this over the IO-Link value. And if I had a big block of ice, stick it in there, we watch it dip all the way down. And if you come from the PC world and you're new to automation, you can almost think of the IO-Link master as almost like a motherboard. And if you're using it in this application and you're trying to detect when something starts freezing, as it gets down below 32 degrees and we start detecting ice, ice baby, it sends a 16-bit word to its mother. All right, that was a reach for that one. But anyway, that's an example of the temperature probe. Now, if we go and look at our Q5X, this is a laser distance sensor. Can you see it? And now we're going to be getting readings in actual millimeters. And the LED must be on the target. So now we know that our output is on and our stability is good, but more importantly, we're getting this measurement reading. Again, instead of having to deal with analog, we can deal right with the millimeters coming on through. Now we talked about
Hey, we had a question. What PLC are you using to be able to do what you're doing by displaying the values and all those types of things?
Great question. I'm actually not using a PLC. I mentioned that these blocks all communicate over Modbus TCP. I'm actually just using the Redline HMI as a Modbus TCP master to communicate to the devices. Good question. And now we mentioned the data storage mode. So So here I've got this Q4X, which is just one of Banner's flagship sensors. And I use it on different machines. The machine with this I/O block and the machine with this I/O block. So first, let's plug it in over here. And it should...
Hey, Carter.
Hey, yep.
While you're screwing that in, what is that? Why do you have just a loose fiber optic on your demo board?
Oh, this here? Well, lately my doctor told me that I should start adding fiber to everything. So I wanted to be a good patient, and now I do it regularly. Great question, Kurt. All right, can y'all see the display here? To show you what mode it's in, this sensor, you should be able to see those 3 dashes across the top. This is in what we call dual mode, and it reads out in percentages. So in this machine, I use it in dual mode, but in my other machine, I use it in just a distance measuring mode. So I leave it on the shelf with just a, as factory defaults. And now, if I bring it over, and these are always 359 degrees in the wrong direction, and I'll power it up, instead of reading out in percentages, now it's reading out in millimeters. So just connecting it to that port, it overwrote the configuration and put it in the right mode. In fact, now you can see that it doesn't have those 3 LEDs anymore. So now I just, 3 in the morning, took a new sensor, plugged it in, and now I'm ready to run. What else is on the board? It's not hooked up, but this is that encoder. It's a contactless encoder. So we have an inductive target, and it's just got to be within a certain range, and it monitors where you are in a complete single turn, and as long as there's power to it, it will also record the turns. So with power applied, without power applied, it's a single turn absolute device. With power applied, it turns into a multi-turn absolute device. So if your process stops when it loses power, you could use this as an I/O link multi-turn absolute positioning device. Let's see here, Kurt. Did I miss anything on the big board? I don't think I missed anything on slides.
No, I think you're good to go. I'm going to go ahead and drop for everybody a survey in the chat box. We would greatly appreciate it if you would take a look and fill this out for us. It helps us know how we can improve, and then also other technologies that you'd like to see demonstrations of as we continue moving forward with these online presentations. So if you can, take a look at that survey, click the link, and it's just a couple questions. We'd greatly appreciate it.
Yeah, I really want to appreciate everybody taking the time out and joining us today.
Yeah, absolutely. We're going to stick around for some questions. So if anybody has anything else they'd like to ask Carter regarding IO-Link, we'll stick around for that. We're also available to talk about applications offline if that's something you have. If you do need to implement some IO-Link, want more information, would like an in-house demonstration, please get with whoever invited you or your local automated dynamics guy. If you don't know who that is, feel free to give us a call. And we can get you hooked up with the right person. Our website's adcreps.com. Be on the look for a follow-up email that's going to have some information regarding IO-Link in it, and also a recording of the presentation. So if you've got any coworkers that missed it or any kind of information you'd like to retain, we will be sending out a link to the recording. But other than that, we'll stay online for a few more minutes to field any kind of questions. And if you need to jump off, feel free to go ahead and do that. But thank you so much for attending.
Yeah, also, we're doing this again at 2 o'clock. So if you know of anybody else that might benefit from this, please let them know.
Yeah, or if you just really find Carter humorous, you're welcome to join it too again.
Well, that would be everybody, right? Okay.
I think it'd only be if your mom here, then she'd join again too.
What's that?
I said maybe if your mom had attended, she would join again at 2.
Without a doubt.
You're right.
Without a doubt.
Yeah, that board turned out well. You can see the Q4X well.
Oh, good. Good. I really couldn't tell, and I thought that was a good way of showing the overwrite easily.
Absolutely.
Yeah,
And
I was pretty happy with
the
it.
TL50, great.
That's awesome. The other light still just kind of blares, doesn't it? Of course, it's not really
Another
diffused
question,
either.
Ross, can you program an IO-Link capacitive sensor sensitivity with a data storage mode?
Well, you
So
should be
you
able
don't
to.
set that threshold, that switching threshold.
Yeah, I will say it depends on the device. I ran into a device this weekend I was trying to do data storage mode on, and it wouldn't accept it. And so it could potentially be that some devices don't accept that, which I'm going to look into. But in fact, I probably have a capacitive IO-Link here. Maybe. If so, I'll try it, but I may not. That's a great question.
That is a great question, because I can see that as an awesome application for plastics plants where, you're having to go replace those in the silos just from static